G'day, I'm Dr. Philip Button from the Food Microbiology Academy. Now, in this second session of our series, our 5-part series on HACCP and GMP, I want to start with dairy product transmission, dairy. G'day, I'm Dr. Philip Button from the Food Microbiology Academy. Now, this is our second session in our 5-part series on HACCP and GMP. So without any further ado, I'll just get straight into it, share my screen, and we'll be off and running. Okay, so what we want to do here, apologies, just rearranging some things on my screen here. Okay, now what we've got G'day, I'm Dr. Philip Button from the Food Microbiology Academy. Welcome along. This is our second session in our 5-part video series on HACCP and GMP. So without any further ado, I'm going to share my screen and we'll get straight into it. Okay, there we go. So this time we're going to be starting off talking about specific practical example, control of dairy pathogen transmission. So in the dairy environment, there's really many opportunities for pathogens to enter. So if you think about it, on the farm for a start, there's the normal cow flora. So the normal flora of the cow, which may or may not be pathogenic, but even if they are, they might be causing asymptomatic infections, as well as, of course, the fecal material. In particular, E. coli 0157 H7 is, of particular concern, and there's been, numerous documented cases of the particular serotype of E. coli causing disease in a range of agricultural products. So, in addition to the normal flora, asymptomatic or subclinical infections, then there are mastitis pathogens, E. coli and Staphylococcus aureus. So, of course, with mastitis, there are subclinical infections that are, also problematic. Then the milking shed environment, actual equipment that's used, if it's not cleaned properly, personnel, so the staff, which can transmit pathogens from one area to another. And you can imagine in the milking shed environment, there's a high chance of aerosols to be, which can be generated. And as a result, there's potentially pathogenic microorganisms originating from all these sources that I've just mentioned on from the animal itself, that could end up on people, on equipment, get transferred to other animals, get transferred to milk, but then of course the housing area. So the plants, the mud, the soil, in summer, from the pasture, or if they're indoors, such as in winter, then we've got bedding materials that can harbor dairy pathogens. So really, when you think about it, there are just so many possibilities where pathogens could enter into dairy products. that's just from the actual farm environment. But how about in the manufacturing processing environment? Well, the importance of cleaning, really can't be underestimated, can't be overemphasized enough, really. Not only have we got, potential for pathogens, from the raw milk, but then, what happens when they go into the bulk tank on the farm? If the temperature control is not good, or if there's every other day collection, for example, and then that can cause problems. So I've mentioned the collection intervals, but pipes and stopcocks and those sorts of things, very careful attention needs to be paid to those because of the occurrence of biofilms, which can really be problematic and difficult to access and even more difficult to clean. So again, we're talking about collecting pipes in the tanker and biofilm. So on the farm and the tanker in the processing environment, really once they get a foothold, they're really difficult. And so the best way is really prevention is better than cure. You can't clean enough, really, when it comes to ensuring that you don't have biofilms building up. So that's in a specific context of where pathogens can come from, where they can originate from in the case of dairy products. And we've just gone through the actual agricultural environment, milking environment, then the processing plants. And those are examples of critical control points, really, and areas that would need to be paid particular attention to when developing a HACCP plan. So what is a control point? So if you just think back to the last couple of slides, any point, step or procedure at which, and remember, it's not just food safety, so it's not just microbiological, at which biological, physical or chemical factors can be controlled. So if we're looking back to the previous slide, and we've mentioned about biofilms a few times, then a control point could be the actual cleaning, to ensure that biofilms don't develop. So that leads us on to a critical control point, so a CCP. So that's defined there as a step, point, or procedure at which a control can be applied and is essential to prevent or eliminate, or all but eliminate a food safety hazard or reduce it to an acceptable level. So taking that example, if the biofilm is a control point, because you can potentially control that biofilm from developing, establishing in the pipework of the farm bulk tank, then that would mean the procedure, so the point of cleaning, could be the critical control point, because that is something that can be applied. And it's absolutely essential to be able to prevent that specific food safety hazard. So control points where quality factors can be controlled, and points where non-HACCP regulatory requirements can be controlled. So control points are more likely to be related to food preservation, those sorts of areas, so spoilage, whereas critical control points are those where food safety hazards can be controlled. So we're talking about a difference here between quality and safety hazards. Now, how about identification of a critical control point? So control points may be identified as a critical control point in these particular cases when the hazards can be either prevented. So a chemical hazard can be prevented by control at the formulation or ingredient addition step. So that would mean actually reformulating, so that hazard or that chemical that you have as part of your ingredient is not actually there at all. So it's been eliminated, it's been prevented. Or at the ingredient addition step, you can have a particular prevention mechanism which enables or disables that particular chemical from finding its way into the food. So elimination, on the other hand, is removing. So in this case, we've got metal fragments as the example. So these can be detected, and then a metal detector, detected by a medical detector, and then removed from the contaminated product on the processing line, or reduced to acceptable levels. So reduction to acceptable levels is more to do with microbiological hazards, especially those associated with quality. So meaning it's not something that's typically associated with safety, because if you think about Staphylococcus aureus, salmonella, those sorts of things, those need to be eliminated. Whereas because any amount is not acceptable. And the examples we've got there are biological, as I've just mentioned, or chemical hazards, like shellfish. Ensuring you're harvesting shellfish from safe and approved waters. So a critical control point can be used to control more than one hazard. So the example there is a refrigerated storage critical control point can be used to control both pathogen growth and histamine formation. On the other hand, though, and this is basically the principle of hurdle technology in food safety and food preservation, more than one critical control point might be needed to control a hazard. So we've got the example there of a cooking step and a patty forming step as critical control points in controlling, for example, E. coli 0157H7 in cooked hamburger patties. Critical control points are product and process specific. So it's important to remember that they need to be personalized for a specific product on a specific manufacturing processing line. So they may change when you change your plant layout, the formulation of your product, the actual process flow, the equipment that you're using, the selection of ingredients or the supplier of your ingredients, and the sanitation and support program. So basically, anything that you change in how you go from raw materials to your end product, if there's any changes whatsoever, that would mean that you need to update your HACCP plan, because the critical control points could very well change. Now, critical limits. So that's a maximum or a minimum value to which biological, chemical, or physical parameters must be controlled at a critical control point to prevent, eliminate, or reduce to an acceptable level the occurrence of a food safety hazard. And in this particular case, we've got an example here where the hazard are bacterial pathogens. So an example of a microbiological hazard. And the critical control point is the pasteurizer. So we've got, again, we could use E. coli 0157 in milk as the example. So the hazard are the E. coli bacteria. The critical control point is the pasteurizer, which is where the hazard could be eliminated. And the critical limit for that is the standard pasteurization conditions of 72 degrees centigrade for 15 seconds, which is the standard pasteurization conditions for elimination of pathogens in milk. So this is how it all fits together. We've got a hazard, we've got the hazard, we've got the critical control point, and then the critical limit that we need to apply at that critical control point to ensure that the hazard is, in this case, eliminated. But how about monitoring? Just going ahead. So we've got a couple more slides here. So how about monitoring? So we've got the critical control point monitoring, where we need a planned sequence of observations to actually make sure that that critical control point is doing what it's meant to do. So we've got the under control, producing an accurate record. So we need to monitor, second point, to track the operation of the process and enable the identification of trends toward a critical limit that may trigger process adjustments. So we need to ensure that the temperature, if the temperature, for example, starts dropping, then that's the critical of the pasteurizer. Then that is where we need to. That's an example of the limit that we need to be monitoring, and this enables the identification when there's a loss of control. So the loss of control is defined as a deviation that occurs at the critical control point. So we've got the 72 degrees as the critical limit, for example, and we've got 71 degrees that the pasteurizer is acting at, then that's a loss of control, because the deviation has occurred at the critical control point from the critical limit of temperature of 72 degrees down to 71 degrees. And therefore, we need documentation of the process control system to make sure that it is actually being documented. So usually a measurement or observation to assess if that critical control point is operating within that critical limit. So in the case of our pasteurizer example, we need to ensure that it is operating at 72 degrees for 15 seconds. How? So physical, chemical measurements, observations. So we need to, data log or otherwise make sure that we're real-time monitoring what is actually happening at that pasteurizer with regard to the temperature and the time. So yeah, it needs to be real-time and accurate. We need to ensure that we are making accurate measurements, and the temperatures and times need to be constantly real-time monitored. Continuous or intermittent is the frequency and who. So, clearly somebody who's actually trained to perform these specific monitoring activities needs to do this so that they know what is actually going on and to be able to interpret that. That is where we'll stop for the second session here. I'll just stop my screen sharing and say, yes, thank you very much for watching this particular video. That is session 2 of our 5-part series on HACCP and GMP. I'm Dr. Philip Button from the Food Microbiology Academy, and I really look forward to your company for our session 3 when we post it here on YouTube and also on our blog. So once again, thank you so much for joining. Hope you've learned something here, and shall look forward to seeing you next time. Take care, and all the best until then. Bye.